Hello everyone, I am Dr. Sunil Shingade and I am presenting the research carried on LNG bunkering and LNG tank behavior with technical limitations and feasible solutions. What is LNG? LNG is the liquefied natural gas. It mainly contains methane, more than 90% contains methane, and remaining others like ethane and higher hydrocarbons like propane and others. The boiling point of LNG is minus 162 degrees Celsius at 1 bar of saturated or equilibrium vapor pressure. Because of having low boiling point, it is called as a cryogenic liquid and therefore it is carried as a boiling liquid. The flammability limit of LNG vapors lies between 5 to 15% by volume in air. Below 5% fuel efficiency takes place and therefore continuous fire is not possible, and above 15% the oxygen deficiency occurs and continuous fast does not take place, but between 5 to 15% by volume in air LNG can catch continuous fire. Then what is the LNG bunkering? Bunkering means the process of transferring fuel to ship for its own consumption, and LNG bunkering means transfer LNG as a fuel to ship for its own consumption. Why LNG bunkering is needed? Because currently heavy fuel oil is the main marine transportation fuel, but heavy fuel oil contains is the main marine transportation fuel, but it contains huge amount of sulfur, that is 5000 ppm, means 5000 mg per liter of HFO. Heavy fuel oil means 5 gram per liter of heavy fuel oil, and it is too much. And the other thing is, once once the sulfur oxide released from the combustion of the ship engine, then it is almost 2700 times higher than the road vehicle. Therefore, International Marine Organization set the pollution standard according to which nitrogen oxide has to reduce by 80% and the sulfur content in the fuel has to reduce below 1000 ppm, which is currently in the range of 5000 ppm, and which is therefore it is need of our to reduce it from 5000 ppm to 1000 ppm. And the alternate fuel, clean fuel, is the LNG, which is the cheap and which achieves the pollution standards decided by International Marine Organization. Then what is the existing LNG bunkering protocol? As per the existing LNG bunkering protocol, pre-inerting is necessary to carry out, because to displace oxygen by inert gas nitrogen, and pre-inerting is carried out till the composition of oxygen in the exit stream reaches equal to or less than 1%, and pre-inerting is followed by purging. Purging is carried out to displace nitrogen by LNG vapors, and it is carried out till the LNG vapors get detected inside the exit stream. Then purging is followed by cooling. Cooling of bunker lines I have to carry out to the temperature of the LNG to be bunkered, and once the cooling operation gets over, then actual transfer operation can be initiated. And once the transfer operation, during transfer operation, LNG fuel can be transferred from a storage tank to the LNG ship's fuel tank. Then once the transfer operation gets over, then it is necessary to drain out the LNG from the bunker lines. Otherwise, it gets warm, vaporized, and pressurize the steel structured pipelines and the flexible hoses, and finally burst out these pipelines and hoses. Therefore, it is necessary to carry out the draining operation. And once the bunker lines are drained, once the LNG from the bunker lines get drained out, then there is need to carry out the post inerting, in which we have to displace LNG vapors by inert nitrogen, and post inerting has to carry out till the composition of LNG vapors in the exit stream reaches equal to or less than 1%. This is the brief graphical presentation of the existing LNG bunkering protocol. First of all, connect the hoses and pass the nitrogen through the bunker line for carrying out the pre-inerting. Pre-inerting is followed by purging. Purging is carried out by displacing nitrogen by LNG vapors. Purging is followed by cooling. Cooling is carried out. Cooling of the bunker line is carried out to cool the bunker lines to the temperature of the LNG to be bunkered, and once the cooling operation gets over, then actual transferring can be initiated, and once transfer operation gets over, then it is necessary to drain out the LNG from the bunker line, and after draining there is necessary to remove the LNG vapors from the bunker line by passing the nitrogen, which is called as a post-inerting, and once the post-inerting operation gets over, then we can disconnect the hoses. This is a possible LNG bunkering system designed on the basis of existing LNG bunkering protocol, but there are some limitations associated with the existing LNG bunkering protocol. Pre and post inerting operations are time consuming and nitrogen is needed to carry out these operations. Therefore, nitrogen on generation system should be available there. Therefore, it is economically not feasible or beneficial. Then during purging, there is the exit of LNG vapors from the bunker pipelines, which forms the flammability zone in the vicinity of bunkering system. Then cooling is also time consuming. Draining, during draining there is a possibility of LNG get trapped inside the seal structure, which will get warm, vaporize and pressurize the hoses and steel structured pipelines. Therefore, finally these pipelines and hoses get burst out. Then during post-inerting there is the exit of LNG vapors, and these LNG vapors forms the flammability zone in the vicinity of the bunkering system. Therefore, it is necessary to burn these LNG vapors before going to allow pass to the open environment. Therefore, incineration unit has to assemble there, and it is economically not beneficial and environmentally also not friendly. Then the gas chromatography is needed to detect out the composition of oxygen in the exit stream while the pre-inerting operation is in progress, and to detect LNG vapors while purging and post-inerting operations are in progress, and implementation of gas chromatography is economically not feasible. It is necessary to predict out the time layout of the existing LNG bunkering protocol. This is the pilot plant in which LNG can be bunkered from the storage tank to the ship's fuel tank. These are the specifications of the piloting system which we have simulated. Time required for pre-inerting and post-inerting has been estimated on the basis of exit age distribution, means RTD study. The time required for purging is nothing but the time equal to half of the residence time, and the cooling time has been estimated by doing the heat balance across the bunker pipeline. The time of transferring has been estimated on the basis of the total volume need to be transferred and the flow rate of the transferring flow rate of LNG. The time required for drainage has been estimated on the basis of the volume of the bunker pipeline and the draining flow rate of the LNG. But this is too much time consuming. It is not easy to operate. The existing LNG bunkering protocol is not easy to operate. It is time consuming, and nitrogen is needed for carrying out through pre-inerting and post-inerting. Therefore, it is not economically feasible, and there is need to burst out the LNG vapors which are going to exit from the purging and post-inerting operations, and therefore there is need to burn out all these LNG vapors, which is not environmentally beneficial or environment friendly. By considering all these technical limitations, we have invented the new protocol, which is called as novel LNG bunkering protocol. As per the novel LNG bunkering protocol, we have to apply vacuum and suck the air content from the bunker lines, and once the air gets removed from the bunker line by applying vacuum, then cooling of bunker lines can be initiated by passing the LNG vapors through the bunker line. And once the cooling of the bunker line occurs to the temperature of LNG to be bunkered out, then actual transferring of LNG can be initiated. And once the transfer operation gets over, then there is a need to drain out the LNG from the bunker line. And once the drainage gets over, or draining operation gets over, then the bunker line contains only LNG vapors, and that we have to suck by applying the vacuum and to pass these sucked vapors to the LNG storage tank. And once the vacuum of 760 mmHg gets developed inside the bunker lines, then we can say that there are no any content of LNG vapors inside the bunker lines, and therefore we can pass the air inside the bunker line for pressure recovery. And once the pressure recovery is done, then we can disconnect the hoses. This is the brief graphical representation of novel LNG bunkering protocol. First of all, connect the hoses and apply vacuum to suck the air content. And once the vacuum gets developed inside the bunker line, we can pass the LNG vapors and can circulate these vapors through the bunker line to cool down the bunker lines to the temperature of the LNG to be bunkered. The cooling operation is followed by transferring. Once the transferring gets over, then we have to carry out the draining of LNG from the bunker lines to the storage tank. And once the draining gets over, then we have to apply vacuum and suck the LNG vapors. And once the LNG vapors gets removed from the bunker lines completely, then we can pass air inside the bunker lines for pressure recovery. And once the pressure recovery is done, then we can disconnect the hoses. This is the possible LNG bunkering system designed on the suggested or invented novel bunkering protocol. The prediction of time layout for the novel LNG bunkering protocol has been estimated, and it is compared with the existing LNG bunkering protocol. From this study, it is observed that novel LNG bunkering protocol is time efficient as compared to the existing LNG bunkering protocol. These two protocols has been compared on the other basis also, on the other aspect, by considering other aspects. The first aspect is need of nitrogen. As per the existing protocol, pre and post inerting operations has to carry out, and therefore nitrogen is needed for that, and which increases the capital as well as operating cost. But as far as novel protocol is considered, there is no pre or post inerting operations has to carry out, and therefore there is no need of nitrogen. Therefore operating cost and capital cost can be reduced. The implementation of gas chromatography is the second aspect. As far as existing protocol is considered, there is a need to detect out the composition of the oxygen in the existing while the pre-inerting operation is in progress, and also there is a need to predict out the composition of LNG vapors while the purging and post-inerting operations are in progress, and therefore gas chromatography is needed to detect out these compositions. Therefore, a gas chromatography is needed in existing protocol, but in as far as novel protocol is considered, purging operations, pre-inerting and post-inerting operations are completely avoided. Therefore, there is no need of implementation of gas chromatography. Third one is the incineration unit. As far as existing protocol is considered, the LNG vapors are going to release from the bunker lines while the purging and post-inerting operations are in progress, and therefore we have to burn these LNG vapors before going to escape those to the open surrounding, and therefore incineration unit has to assemble. But as far as now, therefore, capital cost of the project increases, and if we are burning the LNG vapors, then it is not environmentally beneficial also. But as far as novel protocol is considered, there is no, we are avoiding the purging and post-incineration operations also. Therefore, there is no need to install the incineration unit. Therefore, it is economically feasible and environmentally also beneficial. Then we have developed the one more protocol which is called as accelerated LNG novel LNG bunkering protocol. In the accelerated novel LNG bunkering protocol, we use the vacuum to suck the air from the bunker lines, and once the bunker lines are evacuated completely, then we are initiating the transferring operations. We are not doing the cooling operations. Why, we will explain later on. Then after, once the transferring operation gets over, then we are carrying out the draining of the bunker line, draining of the LNG from the bunker lines to the storage tank. And once the draining operation gets over, then it contains, then the LNG bunker lines LNG gets, once the draining operation gets over, then the LNG vapors might be present inside the bunker lines, and that we have to remove, and therefore we are applying the vacuum once again to suck these LNG vapors and pass these LNG vapors to the storage tank. The applied vacuum not only sucks the LNG vapors but also vaporizes the LNG trapped in the seal structure. Therefore, possibility of getting burst over the period of getting burst of the seal structured pipelines or the hoses is completely avoided. And once the LNG vapors get removed completely from the bunker line, then pressure recovery has to do by passing air inside the bunker line, and once the pressure recovery is done, then we have to disconnect the hoses. The air, we avoided the cooling operation, which is too much time consuming. The scheme, graphical presentation of the accelerated LNG bunkering protocol is as follows. First, connect the hoses and apply vacuum and suck the air content. Once the air gets removed from the bunker line, then the transferring operation can be initiated, and once the transfer operation gets over, then the draining operation can be initiated, and draining operation is followed, and once the draining operation gets over, then the LNG vapors from the bunker line can be removed by applying vacuum, and once the complete LNG vapors get removed from the bunker lines, then pressure recovery can be done by passing the air, and once the pressure gets recovered, then we can disconnect the hoses. The confidential part is the how to avoid the cooling operation. The cooling operation has been avoided by constructing or by designing the seal structured pipelines and seal structured pipelines and the hoses in such a way that there is no need of carrying out cooling for every cycle, and the design hoses and steel pipelines should be capable to sustain the negative pressure when we are applying vacuum inside the bunker lines. This is the novel part on which we have filed the patent. This on the there is almost from in world is doing the research on this topic from almost last 25 years, but they are not coming across the the exact path of how to carry out the LNG bunkering, and they developed the existing LNG bunkering protocol, which we have discussed already, and this protocol is approved by the American Bureau of Shipping, and it has so many limitations as we already discussed, and therefore we developed another protocol, that is novel protocol, which is easy to operate, time efficient, and economically feasible and environmentally also beneficial. Then we are coming across the second problem of the LNG bunkering, because the rollover phenomena of the LNG storage tank is the major problem. What is the rollover? Rollover means inside the storage tank the rate of generation of biomass gas increases 10 to 100 times more than the normal value, and therefore pressure inside the tank increases and pressure relief valve gets open, and huge amount of LNG vapors get escaped to the open surrounding. Sometimes it causes damage to the LNG storage tank, and the basic reason behind this is as follows: because of the density difference between the parent LNG and the filling LNG. That difference comes in the density due to difference in temperature or difference in composition or difference in both. And if the parent LNG and the filling LNG not mixed properly, then the two layers gets formed. That is we call stratified layers, and high density layer resides bottom side and low density layer resides upper side. And if the density difference between these two layers is more than or equal to 5.5%, then the convective loops going to form inside the lower layer due to the heat sink. They are not going to reach or to the top surface of the LNG, because they do not have sufficient buoyancy to reach the top surface of the LNG and to lose the heat absorbed in the form of latent heat of evaporation. Therefore, heat going to stored inside the lower layer, which is we call as thermal overfill. But as far as the top layer is considered, the heat sink is going to lose continuously by surface evaporation. Therefore, temperature of the upper layer almost remains same, and therefore its density almost remains same, but remains same with the period of time. But as far as the lower layer is considered, then what happens, or the bottom layer is considered, then as heat going to not release continuously by evaporation, it is going to store inside in the form of sensible heat content, because the convective loops going to form do not have sufficient buoyancy to reach the top surface and release the heat in the form of latent heat content. Therefore, they store that layer stores the heat in the form of sensible heat content. Therefore, with the period of time, its temperature increases and its density decreases. And the time comes when these two layers, when these two density of these two layers becomes equal, at that time instant mixing takes place, and therefore the thermal overfill of the lower layer gets released in the form of latent heat of evaporation, and huge amount of boil of gas generate, and that is 10 to 100 times more than the normal boil off rate, and which increases the pressure inside the tank, and that can damage the tank also, and or opens the pressure relief valve and get released to the open surrounding. And the other thing is, when two layers mixes vigorously, then the heat of mixing is also responsible for increasing the rate of generation of boil of gas. And this rollover phenomena is first observed in 1972, and after that there are 40 events of rollover phenomena are occurred in world with cryogenic liquids, but scientists didn't reach still to the ideal solution how to prevent the LNG bunkering, how to prevent the LNG or any cryogenic liquid rollover phenomena occurring inside the storage tank. Therefore, we come across the ideal solution about that. about how to solve this problem and how to control if accidentally LNG rollover phenomena occurs with the cryogenic liquids. These are the feature. These are the factors we have to consider during the rollover phenomena. During rollover phenomena, instant mixing between, as we discussed earlier, instant mixing between two stratified layers occurs. Therefore, boil off rate increases 10 to 100 times of the normal as compared to the normal rate, and therefore that increased boil off gas generation rate opens the pressure, increases the pressure, and therefore pressure relief valve gets open, and these vapors get escaped to the open atmosphere, and otherwise it can also cause damage to the storage tanks, and it is very risky to the surrounding human beings. And how to avoid the rollover phenomena, because world scientists didn't reach to the proper solution till today's date, but we have given the proper and novel solution to this rollover phenomena. To avoid the rollover phenomena, it is necessary to carry out the proper mixing between the parent LNG and the filling LNG. The mixing should be gentle, and it should be throughout the entire liquid holdup of the storage tank. Then if heavier LNG, if the filling LNG is heavier, then it has to spray from the top side. If the filling LNG is lighter as compared to the parent LNG, then it has to fill from the bottom side. And what will be the internal structure? We have to use the multiple plates. These are located one above other, multiple plates, by providing some distance between them. These plates are placed one upon another horizontally, and all these plates are having the central hole as shown in this, and there is a clearance between the tank wall and these plates. And once we are spraying heavier LNG from the top side, then what will happen? These plates are having the number of holes on its surface, horizontal surface, and the holes of the two adjacent plates should not have the same vertical axis. Therefore, what will happen, once this sprayed LNG drops down, then it starts to spread across the entire cross-sectional area, and once it passes through the bottom side, then it will get mixed throughout the entire liquid holdup of the storage tank, and therefore proper and gentle mixing can be carried out, and therefore possibility of occurring layer stratification can be avoided completely. And if the filling LNG is less dense as compared to the parent LNG, then it has to fill up from the bottom side. In this situation also, we have to arrange the multiple plates which are placed horizontally and placed one upon another, and by providing some distance between them. All these plates having the same central hole, and there is a clearance is maintained between the tank wall and these plates, and the multiple holes are provided on the horizontal surface of these plates, but the holes of the two adjacent plates should not have the same vertical axis. And once the LNG is pumped from the bottom side, then what will happen when it rises? Then it starts to pass through these holes and starts to spread across the entire cross-sectional area. When it passes in the upward direction and get mixed throughout the entire liquid holdup of the storage tank. Therefore, the gentle and uniform mixing can be carried out throughout the entire volume of the storage tank. Therefore, the possibility of the occurring layer stratification can be avoided completely. And if unfortunately layer stratification occurs, even after that, even after this novel implementation, then what will happen? These plates controls the mixing rate while the rollover phenomena occurs, and therefore the rate of generation of boil off gas can be controlled and will be maintained below the desired safety limit. This technique not only prevents the LNG or any cryogenic liquid from forming stratified layers, but it also prevents or controls the rollover phenomena if it often occurs accidentally or unfortunately. Thank you. The conclusion summary of the LNG bunkering is as follows. The existing LNG bunkering protocol is developed by the researchers working all over the world in last 25 years, and that protocol is approved by American Bureau of Shipping, and this protocol is called as existing LNG bunkering protocol. As per this protocol, we have to carry out pre-inerting, purging, post-inerting also. These operations are time consuming, not easy to operate, economically not feasible, and environmentally not beneficial. Therefore, there is a challenge in front of bunkering world of how to carry the LNG bunkering in a simple way. Therefore, we have given the novel protocol to the LNG bunkering world, according to which we can design vacuum assisted LNG bunkering system. But the basic problem in implementation of this novel protocol is to design the hoses, flexible hoses, and steel structured pipelines which can sustain the negative pressure. Therefore, we have designed or developed the steel structured pipelines and the flexible hoses of the bunkering system in such a way that they can sustain the negative pressure and also avoids the cooling operation, because there is no need to carry out the cooling for each and every cycle. Therefore, it becomes more time efficient, and this protocol we call as accelerated novel LNG bunkering protocol. And the second problem or second technical problem in front of LNG world is the rollover phenomena. And the first rollover phenomena is detected in 1972. The scientists all over the world are doing the research on how to prevent the rollover phenomena and how to control that also. But they didn't come across the proper solution. Therefore, we have given them the technical solution according to which we have placed the multiple plates inside this LNG tank, one upon another. These plates are having the holes across the cross section. The holes of the two adjacent plates are not having the same vertical axis. If we feed the heavier LNG from the from the top side, if we feed the heavier LNG from the top side by spraying it, then it flows down through these walls and gets spread across the entire cross section area of the tank and get mixed thoroughly through the entire liquid holdup of the LNG tank. Therefore, proper mixing occurs and the possibility of occurring layer stratification can be avoided, and therefore the rollover phenomena, the chances of occurring rollover phenomena can be eliminated. In the same way, if we allow to pass or allow to fill the lighter LNG, comparatively lighter LNG from the bottom side, then it rises up through the holes of the plates and gets spread across the entire cross-sectional area of the tank, and therefore it gets mixed out through the entire liquid holdup of the LNG tank. Therefore, the possibility of occurring layer stratification can be avoided, and therefore the rollover phenomena, the chances of occurring rollover phenomena can be eliminated completely. Even after that, if unfortunately layer stratification occurs, layer stratification is the basic cause of the rollover phenomena, and if it occurs unfortunately, even after that, these plates controls the mixing of two layers, the mixing rate of two layers, and therefore the rate of generation of boil-off gas during rollover phenomena can be maintained below the desired safety limit. Thank you.